Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will apply basic transformations to the graph of y equals tan x. So we'll do that by graphing this function here, y equals x plus 45 degrees minus 1. So remember, this one moves it down by 1. This moves it across by 45. It goes in the opposite way that you'd expect when it's inside the brackets. So the 45 is positive, but it will actually move it to the left by 45 degrees. So other than that, this will be the same graph as y equals tan x. So what do we know about y equals tan x? We know it has asymptotes here at x equals 90, at x equals 270, at x equals 450, and so on. So because we've moved the graph 45 degrees to the left, what that means is, instead of the asymptote being here at x equals 90 degrees, it will be here at x equals 45 degrees. And similarly, the asymptote that was here at x equals 270 degrees will be moved here to 225 degrees. So these green lines show you that the graph has moved 45 degrees to the left. So let's look at other points that were prominent on y equals tan x. We know it went through the origin. It also hit the x-axis at 180 degrees, 360 degrees, and so on. So the 45 degrees to the left on the x-axis means instead of hitting the origin here, it will hit the x-axis here at minus 45 degrees, here at 135 degrees, and then again at 315 degrees, and so on. But because of the minus 1, the fact that it's shifted down, it'll actually be shifted down to here, here, and here. So it will go through those points in blue rather than those points in black. Now, what else we know about the tan graph? Well, we know that tan of 45 is equal to 1. So normally, the graph goes through the point 45, 1. So because it's being shifted 45 degrees to the left, you'd expect it to go here. But then because it's down 1, it will be moved to this point here. Similarly, tan of 225 degrees is 1. But we've shifted the graph 45 degrees to the left and down 1. So it will actually go through that point there. You can probably see it will also go through that point there. So other than that, it will look like the tan graph. So it gets closer and closer to its asymptote. It then sort of changes direction, and then it gets closer and closer to the next asymptote. And that's what will happen here. It looks exactly like the tan graph. It's just been shifted to the left and down. So closer and closer to the asymptote, and then closer to the next asymptote. So that's what the graph will look like. I know tan graphs are a bit harder than sine and cos graphs, but please make sure you ask questions if you don't understand. Thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.